So when we talk about connected bodies over a smooth fixed pulley, we are looking at this fixed pulley and two particles, let's say they are A and B, particle A, particle B, connected with a string that is taut, and let's say the mass of particle A is 3 kgs and mass of particle B is 2 kgs. And the question says that find the tension in this string and acceleration of the particles. They are held together when they will be released. This is obvious that A moves downwards and B moves upwards depending on their masses. So we always write these equations for A. In case of A, I know that A is moving downwards. That means weight is more than the tension. Tension would be upwards. Tension is always considered away from the particle. If we would talk about this pulley, tension would be downwards in that case. So we are talking about A, that is upwards. Weight brings it downwards. Weight is pulling it upwards is equals to mass into acceleration. We are basically making this equation F equals ma, where F is net force. So downward minus reverse force equals ma, and we fill in the values. Weight is 30 minus tension equals 3a. This equation is for A. Then we make equation for the other particle for B. B is moving upwards, indicating that tension is more than the weight, equals ma. Now tension minus weight is 20, mg mass into gravity is 20 equals 2a. Now we have these two equations and we can solve them simultaneously. So let me write it as this is 30 minus t is equals to 3a, and the other one is, let me rearrange, and when we add these we get 10 is equals to 5a, and acceleration is 2 meters per second square. In this case we have the acceleration, use any of the equation. T minus 20 equals 2a, t is equals to 2a plus 20, and 2 times 2 plus 24 plus 20 is 24 newtons. So tension is 24 newtons and acceleration is 2 meters per second square. Now question may have different parts. First part is write the equation, second is find the value of t and a, or only one of those. Other would be connecting this question with kinematics. Let me say examiner tells you that this distance is 1 meters, and he says when particle A, just before it hits the ground, it says find the velocity. So then we use the same concept. We have the distance, we have the acceleration. Distance, I can say that is my displacement. Initial velocity is 0, final velocity is unknown, acceleration is known, that is 2. So final velocity would be v equals u plus at, or we don't have the time, so let me use v square minus u square is equals to 2as. Final velocity unknown, initial is 0, started at rest, acceleration was 2, distance is 1. So that is v square is equals to 4, v is equals to 2 meters per second in the case when distance was 1. On the other hand, second part would be, or parts could be increasing in any manner. When A reaches ground, B is going upwards, and it would always be given that B never hits the pulley. Particle B is moving upward and it never hits the pulley, and he says find the maximum height reached by B. And don't forget, B started from this position which was already 1 meter above the ground, and when A reached down, B would have raised 1 meter more, and then it raises under the action of gravity. And because these objects are connected, initial velocity here was 0, initial velocity here is 0, final velocity at this point is 2, final velocity at this very point when it traveled a distance of 1 meter is 2. Rest of the motion is under gravity. Acceleration was same 2, acceleration was same 2, but now when it is under gravity, acceleration would be equal to acceleration of free fall, which is 10 meters per second square. So we have to work for this situation, and under the action of gravity, we know final velocity would be 0, and for this initial, let me mark it E, initial position was E and velocity was 2 at the point, and let us say this is initial in this case. So V square minus U square is equals to 2AS. Final it is 0, initially 2, and acceleration is negative 10. It is going against the action of gravity, and displacement covered is unknown. So minus 4 by minus 20 is equals to the displacement covered, and we get 0.2 meters. So total distance is 1 plus 1 plus 0.2. If examiner asks the total height, या maximum height reached, so that would be 1 plus 1 plus 0.2, which is 2.2 meters. If the question would have been distance traveled before B comes to rest, distance traveled before it comes to rest, so it was right there, it traveled 1 meter, then it traveled 0.2 upwards and 0.2 downwards again before it came to rest. So that would be 1 plus 0.2 plus 0.2, that is 1.4 meters. Any confusion in this section? A particle of mass 1.6 kgs rests on horizontal table and is attached to one end of light inextensible string. The string passes over a smooth pulley P fixed at the edge of the table. The other end of the string is attached to particle B of 2.4 kgs. So I'm writing 24 Newton weight downwards. This is 1.6, that would be 16 newtons downwards. Hangs freely below the pulley. The system is released from rest with the string taut and with B at height of 0.5 meters above ground as shown in the diagram. In the subsequent motion, A does not reach P before P reaches the ground. Given that the table is smooth, find the time taken by B to reach the ground. Okay, I'm making equations for A and B. Let me use this writing space. So for A, there's only one force which is moving it towards right, that is T. Nothing in the reverse direction because it is smooth. So T equals MA for A. Now we write it for B. B is moving downwards. That means weight is more than the tension, equals MA. So weight is 24. Tension is unknown. Mass is 2.4. And acceleration is unknown. I'm interested to find the acceleration. So I'm replacing this T as 1.6. 24 minus 1.6 A is equals to 2.4 A. 2.4 plus 1.6 is 4. So 24 is equals to 4A. Acceleration equals to 6 meters per second square. Now we have the acceleration for B. We have the initial velocity. It started at rest. We have the displacement, and we are interested to find the time it took to reach. So V equals U plus AT, and V square minus U square equals 2AS, and S is equals to UT plus half AT square. So if I use the third one, I have the displacement which is 0.5, initial speed was 0, eliminating this term, plus half, acceleration is 6 in the case, and T square. So we solve for this. 6 by 2 is 3, 0.5 divided by 3 is 1 by 6, and square root of that is T is equals to square root 6 by 6, which is approximately equal to 0.408 or 0.41 seconds. That was the first part. Second says, given instead that the table is rough. Okay. Table is rough and the coefficient of friction between A and the table is 3 by 8. Find the total distance traveled by A. You may assume that A does not reach the pulley. So So when we consider this scenario that B comes down 0.5 meters, A would also travel because it is connected. It travels 0.5 meters, and we know the acceleration would be 6 meters per second square. So it is traveling from this point to this point, and we have to calculate the tension and acceleration again because it has friction this time. So let's say for A, we have forward, that is tension, minus mu r is equals to ma, and for B equation stays the same, that was 24 minus t is equals to 2.4 of A. Now mu is 3 by 8 and r is 16, so 3 by 8 of 16 to 3 times is 6, that is t minus 6 equals 1.6 A, and 24 minus t is equals to 2.4 A. We solve these two equations simultaneously, and let's make t subject again. 1.6 A plus 6, we replace this on the other side. 24, replacing it with t is negative 1.6 A, and negative 6 is equals to 2.4 A. 24 minus 6 is 18 is equals to 4A. 18 divided by 4 is 4.5. Does it make sense? Now there is friction and acceleration is less than it was before. So acceleration is 4.5 meters per second square. And we know that with this acceleration, A has actually traveled a distance of 0.5. So I can find the velocity at this point, which is v square minus u square is equals to 2as. Final velocity unknown, initial velocity it started at rest, acceleration was 4.5 and distance covered was 0.5. So v square is equals to 2 times 4.5 into 0.5 is 4.5, and square root of the answer is, final velocity at that point is 2.121, and in exact form is 3 square root 2 by 2. Now we have this velocity, and ultimately it has to come to rest, and we know what the frictional force is. Now there is no forward force, and we have to find the distance it would travel under these conditions. So velocity at this point is 3 square root 2 by 2. There is no pulling force, and it would come to rest, that will be 0. Let's say we have kinetic energy at this point which goes to 0 at the other end, and kinetic energy at this point would be half mass of this particle is 1.6, half m v square, that is 3 square root 2 by 2 squared. So I'm getting 3.6 joule of kinetic energy is now wasted against friction. So work done equals force into distance. Work done is actually 3.6, and force is the frictional force, which is friction equals mu r. So that was 6 times distance, and 3.6 divided by 6 is 0.6. The distance equals 0.6. Statement is find the total distance traveled by A. So that is 0.5 initially plus 0.6 after that, makes it 1.1 meters. Is it clear?